Okay, our next section of Chapter 11 is Section 8, Theorems Involving Midpoints. We're going to look at the relationships between segments connecting midpoints of different polygons. In fact, the two polygons we're going to look at are the triangle and the trapezoid. Whenever you get done watching the video or reading your book, you're supposed to do the problems on page 697, numbers 1 through 3. Okay, so the first one is the midsegment theorem for a trapezoid. Here I have a picture of a trapezoid for you, and CD is one of the bases and AB is the other base. The midsegment would be FE, and notice that on this side FE cuts side BD in half, and on this side point F cuts CA in half. That's what makes it a midsegment. To find the length of FE, what I would do is I would add 17 and 13, get my answer, which is going to be 30, and then I would take the 30 and I would divide 30 by 2, and the length of my midsegment would be 15. So I take the average of the two bases to get the length of the midsegment. This is the midsegment of a trapezoid. We're also going to look at the midsegment of a triangle. And whenever we're doing a triangle, it's actually just a little bit easier because we don't have two bases, we only have one base, so all we do is take half of the base. So even though in this diagram it doesn't really look like it, what we're saying is that DE is the midsegment of triangle ABC. Now again, to be a midsegment, first it's going to have to be parallel to the base, and it also is going to have to cut these two sides. I'm going to cut into pieces, into the midsegment pieces. So first thing I want to do is I want to figure out the length of BC. Now I could just jump in and use the distance formula here, but instead of using the distance formula, I want to notice something. The y-coordinate on both of the points are the same. So since the y-coordinate's the same, I know that this is going to lay along the y equals -2 line. So all I have to do is find the distance between -12 and 5. Well, the distance between -12 and 5 is 17. So I know that BC is 17. Well, because of this midsegment formula, if BC is 17, then DE is 8 5/10. Now this works on a triangle. Remember that on the trapezoid we average the two bases, but on a triangle we can just take half the base. Okay, so here is called a medial triangle. The medial triangle is made by connecting the midpoints of each side. So in other words, E is the midpoint of AC, D is the midpoint of BC, and A is the midpoint, F is the midpoint of AB. So this is called a medial triangle. Now remember that because it's a medial triangle, this is the midsegment. It is parallel to AC, so FD is half of the length of AC, and that would be FD, the relationship between FD and AC. If I look at FE, FE is parallel to BC, and since it's parallel to BC and it's a midsegment, then it is half the length of BC. Same thing for DE. DE is parallel to BA, so not only is it parallel to BA, it is also half the length of BA. So if all the sides are half the length, then that would mean the perimeter would be half. So the small triangle has a perimeter that is half of the big triangle because all of the sides are cut in half. Here's another problem for us to look at and try to figure out some things. It tells me that the measure of angle, let's see, KOP, which is this one right here. It gives me this measure of KOP. It also gives me the measure of KRN, which is going to be this one up here. So they're giving me two angle measures. Now, remember our rules about parallel lines and angles. Since this angle is 52 degrees, this angle is 52 degrees, and this angle is 52 degrees because they're all corresponding angles. Now, if I know that all of these are 52 degrees, and I know that this one at the top is 83, I can find out what this one is by adding 52 and 83, and then subtracting that from 180. So if I subtract that from 180, that means it's going to be 45 degrees. So that means L is 45 degrees, the RLK, and RPK, or excuse me, RPO is 45 degrees, and RNM is 45 degrees. So now I have all of the angles, and I can also figure out these supplementary angles, so I can figure out any angle in that triangle. Now, the second thing that I want to use on this is I want to use the midsegment theorems. One, we're going to use the midsegment theorem of a trapezoid, and the other one we're going to use the midsegment theorem of a triangle. So the first thing I want to do is I want to look at this, and I know that OP is 8, and they're telling me that they want me to find KL and MN. Well, KL is pretty easy to find because if I look at the triangle without the base down here, I can use the triangle midsegment theorem because KL would be the midsegment, so the length of KL would be half of the length of OP. So since OP is 8, then KL is going to be 4. Okay, so now I need to find MN. Now, to find MN, I have to remember what the trapezoid midsegment theorem is. For the trapezoid midsegment theorem, it says if I take 4 and I add it to whatever that is, so I'm going to call it X. We're going to call it X right now. And I divide it by 2, I should get 8. So I'm going to use what I know about math and think, okay, this up here is going to have to equal 16 because 16 divided by 2 is 8. And to make this equal 16, this side is going to have to be 12. Because 12 plus 4 is 16. 16 divided by 2 is 8. So notice on this problem I used not only the triangle midsegment theorem, I also used the trapezoid midsegment theorem. Okay, so that's all for this lesson. What you need to do now is go to the problems and do problems 1 through 3.